Alright, today's lesson is we're in chapter 7, and we're going to talk about inverse trigonometric functions and their derivatives. And so what I want to do is just show you a quick video here on a sine function, and I'm going to talk about its inverse. Okay. So first of all, here's the sine function, y equals sine x. Here's a picture of it right here. Okay. So with sine we start at 0, right? And this is actually 3 sine x. So it goes up to 3 and then down through pi down to -3 back up to 2 pi. There's one period. This is 3 sine x. It means the amplitude here is 3. Okay? If we take a look at a regular sine graph, all right, 1 would be here, so this would be the maximum point. So there's a sine graph with amplitude of 1, right? And so on like this. If we follow that along, the sine graph that we are going to look at here today looks kind of like this. Now, when we talk about the inverse, okay, of a trigonometric function, the inverse, what that means is, and on your calculator, you can see there's the sine button, and above that is the inverse sign, sine to the -1, okay, inverse sign. So the functions above the buttons on the calculator are the inverse functions, squared, square root, log, base 10. So really what we're looking at is we're looking for y equals sine to the -1x. Now let's think about inverse functions. We know of other inverse functions, and what we did in pre-calculus 30 was we talked about a reflection about the y equals x line. So 1, 1, so here we go. We're going to have a line like this that extends through 0, 0, and that's going to be the y equals x line. And what we did in pre-calculus 30 was we reflected any graph about this line, and we got its inverse. The other thing that we said was an inverse function, you think reverse. That's what I thought. Inverse, you think reverse. And what are we reversing? We're reversing x and y. Alright, so graphically we know that we're going to be flipping this about the y equals x line, but algebraically or equation-wise, what we're going to do is we're going to reverse x and y. So this is where we're going to start to get the equation. Now, x equals sine y, alright, that we know is going to be a little bit different, right? Usually we solve for y. So how do we get y by itself? Well, if I take you over here, and I said to you, well, think of sine of some angle theta equals, let's say, 1/2. Okay, sine of theta equals 1/2. I guess I could think of my unit circle, and exactly 1/2 would bring me to a point up there in the unit circle, right? And so we've got 1/2, and what's this other point going to be? Is it √3/2? Okay. And then √3/2 is going to give us 1/2 here, right? Now, so sine is, remember, cosine is first and sine is second. So this is going to be √3/2, 1/2. And if you don't know what I'm doing here, I'm talking about the unit circle, you might want to go back and review pre-calculus 30 when we talked about that. But the angle that produces a sine value of 1/2 is going to be this angle right here that corresponds to this point in the unit circle, because we've got cos is the first one, and then sine is the second value. And so what is this? This is going to be pi over 6. So theta equals pi over 6. But if you didn't have the unit circle, and weren't able to do this manually by hand, how would you do this on your calculator? Well, you would go inverse sine of 0.5. Gives us 0.52358. Okay, or if we do pi divided by 6, that's that number. See? So on our calculator, we would take the inverse of sine to get theta all by itself, and hopefully you recognize that. Maybe your teacher showed you this, sine to the -1 of both sides. Now I'm getting to a point here, okay? But this is how we can isolate for this angle. Or, go back over here now, how do we isolate for y? Well, we take the sine to the negative 1 of both sets. And that gets rid of the sine function. It undoes the sine function. So we have y equals sine to the negative 1 of x. And that is going to be the equation of the line that we flip into this, we flip about this y equals x axis, okay? So here is the inverse sine, y equals sine to the negative 1. What else can we call that? Well, there are different names that you'll see, and as I reveal the graph here, I'm going to also reveal the names. So you'll see it sine to the negative 1 of x. You'll see it arc sine x. You'll see inverse sine x. You may even see ASN x. So these are all sort of abbreviations for the inverse of sine. We'll use arc sine a lot. That's what we'll use a lot. And here, this really crazy looking graph is what the sine graph in black looks like when you flip it about the y equals x line. So notice that the inverse sine graph is A, and not a function, and B, it goes on forever and up, in the vertical direction here, and forever in the negative vertical direction there. And we can also, determine a few other things, like the domain. We have a domain here that starts here and ends over here. Nothing gets past these points. So we have a specific domain, which actually is going to be whatever the range was for sine, right? So for arc sine of x, the domain is what? Well, what was it here? Positive 1, negative 1 were the boundaries here. So it's going to be the interval negative 1 to positive 1. Okay. And now, in order to make this a function, so here's where it gets a bit tricky. In order to make this a function, we only want to consider part of this arc sine graph. And the part we're going to consider is from here to here. And that's going to look like this. Right, as we see below, it's just this red section here from negative 1 to positive 1. Okay, so we have that as our domain. Good. Now the range, okay, so you see why I've selected this part of the arc sine? Because as soon as this continues, it doubles back on itself. It's no longer a function. So it's not. So y is not a function of x if we go beyond this point. Now what is this point right here? Well, you can maybe make a guess, right? But if we look at our above function here, so the lowest point of the sine graph over here and the highest point of the sine graph over here, what is this, range here? And that's going to be, where, that's the domain, and the range of the other graph, this right here, this is what I'm talking about, sorry. This from here to here is, trying to show you, but that graph doesn't show it well. But it's pi over 2. So the range for arc sine is negative pi over 2 to positive pi over 2. Okay? Now that I've muddied that up completely for you, sorry. Anyway, so it's the red part here. That's what we're going to consider. It's the only piece we're going to consider because that's part of that's the function. All right, so let's review what we've got here so far. Inverse functions are functions where x and y have been exchanged, okay? Inverse, reverse. Graphically, the inverse is a reflection of the original function, whatever that is, about the line y equals x. So there's a bit of summary of what we've learned so far as inverse function goes. Now the derivatives of inverse functions, which we're going to get to, that's the main part of the lesson here today, is we're going to talk about arc sine and its derivative. Now, I'm going to spare you, for this lesson, I'm going to spare you the derivation of this, how we get this. But it does have to do with the Pythagoras' theorem and some substitution and stuff like that, I think. But anyways, I'm going to show you this chart and clean this up just a bit. But the derivative of arc sine is 1 over the square root of 1 minus x squared. So this square root should extend, right, over the whole expression. And arc cos and arc tan are very similar. And if I showed you an example here, this is an example that I worked through with my students earlier. We're going to take the derivative of sine to the negative 1. And so I'm going to just clean this up a little bit for you. What you'll notice is that when we take the derivative of arc sine, we replace it with this formula right here. Right? That's from our chart. So the derivative of arc sine is this. But the reason why I have this out here, and you may know why, because this is not just x in here. This is another expression. So really we have the chain rule happening, right? So we have outside function arc sine, then we have inside function 1 minus x squared. So we take the derivative of the arc sine, the outside function, and multiply it by the derivative of the inside function. So when this is all said and done, this is sort of the process. Okay? We're going to expand this out right here. Expand that. That becomes this. And then we simplify, and I was okay with this answer right here. But you may see in your solutions manual, you may have this answer that's highlighted in yellow down here. So it's just basically we took the x squareds here from this expression out. But anyway, so that's how you would take the derivative of arc sine. Remember that the derivative of sine x, okay, so dy over dx here of sine x, all right, is cos x. Not quite so simple for arc sine, but that makes sense. It wouldn't be as simple. Okay, so that's a little lesson on what is the inverse of sine. Anyways, we didn't get into cos or tan, but this lesson is just sort of what is inverse and what is the trig, the derivatives of the inverse for trig functions. And so we looked at this chart here, and yeah, so that's the lesson for today.